For this week's lab, we'll be doing data acquisition, in short, DAQ, using LabVIEW and ELVIS. So what is DAQ? This is the DAQ that you'll be seeing on LabVIEW. So a typical commercial DAQ card or module allows input of analog signal through an analog to digital converter known as ADC and an output of analog signal through a digital to analog converter known as DAC. In addition, DAQ card often facilitates as an input and output digital signal as well. So as for ADC, it's normally used for sampling, and the sampling of an analog signal occurs at discrete time interval. And also, higher the sampling rate, the better the conversion of the analog signal. It's also extremely important to note that the minimum sampling rate is at least twice of the maximum frequency of analog signal. And as for DAC, it's used to convert the digital input signal that has been generated by the ADC to an analog output, and it is able to generate an AC and DC signal. The performance of it is also determined by the number of samples that is used, and of course, the higher the resolution, the smoother the output of the waveform. So let's start with the practical session of using a DAQ in LabVIEW. So as usual, we will launch our LabVIEW application, and afterwards, click on blank VI. So for today's lab, we'll be doing two examples. One is the DAQ output control VCA, and the other is the DAQ input control VCA. These examples are shown in your lab menu, and you can follow through as well. So for the first example, we will be doing the DAQ output control VCA. So what you need to do is to create a number indicator and a number controller, and also a gauge on the front panel. You also would like to change the name for the number controller to manual set voltage, and the number indicator to control voltage display. Once you have done with the front panel, go back to the block diagram and create a while loop to cover all the elements that you have just created on the front panel. So the next important thing is to create a DAQ assist. So right click on functions under express input, click on DAQ assist. Alternatively, you can also click on the search button and type in DAQ assist. So once the setup window pops up, select generate signal, analog output and voltage, then select device A01. After that you have done, you'll pop out this window. So under the terminal configuration, set it to RSE, and also the generation mode to one sample on demand. So to ensure that the details are set correctly, click on the details, right click, and select change physical channel. So ensure that the channel is set at A01. So with that, click OK, and you will start to build the VI for it. So with that, you just connect all the wires accordingly to the elements, and we are done for the first example. Do remember to save this program as DAQ output control VCA, as we will use the later part for the course. Moving on to the second example, we'll be doing a DAQ input VU meter, and what we need to place on the front panel is a waveform chart and a number indicator. So under graph indicator, select chart and drag it to the front panel. We can also change the name by double clicking it, and for this case I'll change it to voltage. You can also drag the chart to be bigger, change the limits of the amplitude. Next we'll move on to create a number indicator. So drag it to the front panel and change it to data. So once you are done with the front panel, move on to the block diagram And under execution control, select while loop and cover all the elements that you just created. So the next important thing is to create a DAQ assist. So under express input, select DAQ assist. And for this example, we are acquiring a input signal. So acquire signal, analog input, and select voltage. We'll select the physical channel of AI1. So similar as the previous example, we'll change the terminal configuration to RSE and acquisition mode to one sample on demand. To ensure that all the settings are done correctly, click on Details, right click, and select Change Physical Channel, and ensure it's under AI1. If not, just do some amendments and click on AI1 and click OK. After that, it will generate its VI. So you just connect up all the elements together, and we are done for this example. Do remember to save your VI as DAQ input VU meter, as you will be using it for the later of the course. So to generate the signal, click on Instrument Launcher and select Variable Power Supplies. As for the supply source, click on Positive Supply, and by clicking the switch button, you'll be able to see the steps that is generated on the waveform chart. So with that, capture the screen with both front panel and block diagram side by side, and then place it in your weekly logbook. You also can change the generation or acquisition mode to other modes as well, other than just one sample on demand, and also write it in your logbook to discuss your observations. So that's all for today's lab.